Welcome to the new section of this course, Text and Multi-Class Classification with scikit-learn. In this section, we will look at topics such as using LDA for classification, using QDA and SGD for classification, classifying documents with naive Bayes, label propagation with semi-supervised learning. Now let's move on to the video, using LDA for classification. In this video, we will take a look at the grab stock data from Google. Then rearrange it in a shape we're comfortable with. After that, create an LDA object to fit and predict the class labels. And finally, give an example of how to use LDA for dimensionality reduction. So let's start with installing a version of pandas that supports the latest stock viewer. Do so at an Anaconda command line, so add this. Note that your pandas version will be updated. If this is a problem, create a new environment for this pandas version. Now open a notebook and check whether the pandas data reader imports correctly. If it is imported correctly, no errors will show up. In this example, we will perform an analysis similar to the Altman Z-score. Begin with a few imports and by sorting the tickers you will use, the first date and the last date of the data. Now let's pull the stock data. This data structure is a panel from pandas. It's similar to an online analytical processing cube or a 3D data frame. Let's take a look at the data to get more familiar with the closeness, since that's what we care about when comparing with the help of this command. Run it. Nice, you would get the output like this. Okay, so now we need to compare each stock price with its price in 6 months. If it's higher, we'll code it with 1, and if not, we'll code it with 0. To do this, we'll just shift the data frame back by 180 days and compare. The next thing we need to do is flatten out the dataset. Here, this will convert series to data frame. This will pivot a level of the necessarily hierarchical index labels. This will swap levels 0 and 1 in a multi-index and sort it. This is the index names which we'll be choosing from classes. And with the help of these commands, we'll join and rename the class. To get the output, we will use this command. Run this code. And this is the output. Okay, so next we need to create matrices in NumPy. To do this, we'll use the Patsy library. This is a great library that can be used to create a design matrix in a fashion similar to R. After running it, you would get the output as seen here. The Patsy is a very strong package. So now that we have our dataset, let's import and fit the linear discriminant analysis object. We can see that it's not too bad when predicting against the dataset. Certainly, we will want to improve this with other parameters and test the model. Run it, and you will get the output as highlighted here. These metrics describe how the model fits the data in various ways. The precision and recall parameters are fairly similar. In some ways, as shown in this list, they can be thought of as conditional proportions. Precision. Given that the model predicts a positive value, what proportion of it is correct? This is why an alternative name for precision is positive predictive value, PPV. Recall. Given that the state of one class is true, what proportion did we select? I say select because recall is a common metric in search problems. For example, there can be a set of underlying web pages that, in fact, relate to a search term, the proportion that is returned. The F1 score parameter attempts to summarize the relationship between recall and precision. LDA stands for Linear Discriminant Analysis. LDA is actually fairly similar to clustering, which we did previously. We fit a basic model from the data. Then, once we have the model, we try to predict and compare the likelihoods of the data given in each class. We choose the option that is more likely. LDA is actually a simplification of quadratic discernment analysis. QDA, which we'll talk later. Here we assume that the covariance of each class is the same, but in QDA this assumption is relaxed. So here we have come to the end of this video.